Okay, so welcome to the session. Thank you a lot for being here. We're going to talk about orchestrating async processes using Apex deferrable Apex chainables. So you might have seen this quite a lot during the sessions. I would really appreciate if you can give some feedback, leave some feedback, so in that case, we can improve the session in case we can talk it again in another event. Thank you a lot. I know this is pretty much the time for lunch for most of you, and I appreciate you taking the time or even bringing your lunch to the session so you can take advantage of that. I appreciate it. My name is Jonathan Wiesel. I'm a senior technical architect working at 3MT, as you might have seen. And I would really love to tell you more about me, but we have very little time, and I have a lot of things to show you, so I prefer to continue with the content. Here's a quick agenda of what we're going to cover. We're going to talk about what are and why we should use async processes, and we're just going to cover that very superficially because there has been a session yesterday. It's going to be repeated tomorrow about architect guide for asynchronous processing. I would really encourage you to take a look at that one if there is of interest to you, because we're just going to cover a few details in that case. Then we're going to proceed onto the use case of chaining of the async processes, which is usually the one that we struggle a bit in this case. We'll talk about a framework that enables the chaining to be more easy to manage, and we're going also to talk about the challenge beyond chaining, or that we usually face when we are with this kind of use cases. So what are async processes? I'm going to summarize it in just one sentence because, well, again, there are other sessions that talk about this, and it's execute at a later time. When we talk about a later time, it means outside of the main transaction, the transaction that the user submitted the action. So pretty straightforward, right? So these are just a bunch, not all, but a very representative set of the asynchronous processes that are available in the platform. And my favorite one is the decoupled one because of the love that is being given of the last few years for the decouples, which is, for example, Apex cursors, for example, transaction finalizers. It has been given a lot of power to this kind of asynchronous processes. And for the front-end part, my favorite is async await because the simplicity, the elegance that this represents for readability, for maintainability, and so on. So why should we use async processes? And for example, better responsiveness. The user they feel that the system is behaving more rapidly because most of the processing is happening at a later time in a background process. Therefore, there's more room to bring more dot processing for the main transaction, and therefore, it's higher throughput. And therefore, since we're on a multi-tenant environment, we cannot horizontally scale it indefinitely or infinitely. We have a separate set of governor limits that also for async are increased, which is quite good. And we usually say that it's easier to scale, and you can see that it's in italic font because we're going to talk about this a bit later. And the focus of this session, which is those async processes can be run in parallel or they can be run sequentially, which is one of the main challenges we see nowadays in async processing, the need to run sequentially. So back to the easier to scale part, okay? Easier to scale, but it's hard to do it in a way that the system can behave in an expected way if we do not take certain measures to make it do it that way. Such as, for example, error handling. If we're in an asynchronous transaction, therefore all the main actions that the user submitted are already committed to the database. We need to do some other actions to compensate for that if there are errors, or we need to do retry handling and so on. So it's more difficult. The same goes with monitoring. It's something that it's outside the main transaction, therefore the user won't see if there's anything that it's not behaving as expected. We might have also, if we're running different processes, we will also face with dependencies between one and another and make it more difficult. And also, it doesn't necessarily mean that when we want a transaction to be executed in the background or a process to be executed in the background, maybe we don't want it to be run right away. Maybe we want to delay it for when the time is right? So that's also one of the challenges to make it behave in an efficient way that can scale well. So we will talk about a very simple but representative use case of traditional async process chaining. We'll take an example of an opportunity cleaner process that essentially will just delete old closed opportunities because they're not of use in our system. And we will also chain that with a very simple implementation of an integration to an outbound system or an external system, sorry. So it will look something like this. Maybe we'll have a chainable class and the op cleaner class that the implementation is quite simple. I know there's no error handling. Please bear with me. It's for simplification reasons. And apart from just cleaning up, we're going to call a different process in this case because of the syntax. You might have guessed that it's a queuable job that it will trigger the integration to the other system. Therefore, the integration to the other system that is going to be executed as the second chain process, it's just an integration to the external system. Pretty straightforward, right? So what's the issue with this? Those two processes are coupled. We can see that the first is hard coding the call to the second one. Therefore, it makes it harder to maintain, to reuse them, to deploy them because the deployment boundaries become more complicated to manage, and therefore how we can work with that to make it more reusable, more extensible, and be less coupled or totally decoupled if possible. This is where I want to present to you, for the ones that do not know it, the Apex Chainable framework. If you scan that QR code, it's going to lead you to a GitHub repository, because this is an open source project. And if we take a look at the description that states in the repository, it says, chain asynchronous Apex in a readable and flexible way without hard coding the successor. Pretty straightforward, right? The same we were seeing before. We are hard coding the successor from one async process to the other. And however, this is not any open source project. It has been created by these great men here that you might have known. Robert is a Salesforce MVP, 3-time Salesforce MVP. It's pretty much known for the one that ported PMD, the static analysis tooling, to work with Apex. He has lots more than that. You can go to his GitHub profile. You'll see there's a lot that he has contributed to the community. He's now focusing on AI. Unfortunately, he cannot be here to present this with me. I will try to make it up to you on his name. So let's see. Let's talk a bit more about the framework. So this framework works currently with these 3 different types of async processes from Apex: schedulable, batchable, and queuable. And what it does, it creates a new implementation that has 2 main objectives. One is to abstract the concept of, okay, how the different implementations of batchable, queuable, there are different ways to call them, meaning that if you want to execute a batchable method, you will call the database.executeBatch. If you're going to call a queuable method, you will use the system.enqueueJob. So we're going to abstract that, and that's what these classes will do. And why? The reason is why. So because we want to chain them, if they are already abstracted, chaining them, it's easier because we're always working with an abstraction for it. Therefore, you might have guessed that since each of those is an abstraction, therefore, all of them inherit from a common class called a chainable class. Therefore, we can chain those processes together. So let's proceed with that example that we were seeing before, right? So if we tweak it a bit to work with this framework, we can see 4 specific differences in the implementation for the op cleaner. One would be that instead of implemented the schedulable interface, we will see that they now extend from the chainable schedulable class, which is part of the framework. Therefore, That brings us to the second differences. It's not implementing anymore the native execute method. It's now overriding a protected method from the class. Therefore, again, because it's wrapping that behavior inside the framework, and therefore, to the third difference, the context, which is, again, an abstraction of the real context. We can get the specific context for, in this case, the chainable, a schedule, but in this case, again, it's an abstraction. And the most notable difference, obviously, we're not hard coding the successor. So how that will work then to chain the processes together? Again, for the other processes, pretty straightforward. It's pretty much the same as the other one, with the exception that, well, these didn't have any call to any other process, but the implementation will be pretty much follow the same principle. So in this case, we'll have an orchestrator, so to speak, that would be the process that determines how these two other processes will be chained together. Therefore, we were saying that those two implementations inherit from the chainable class, and therefore, when we instantiate them, we can assign them to a chainable variable. And we can use that then method to continuously chain different processes that follow the same implementation pattern. We can do it on, and those will be chained together. And when we trigger the execute method, that will execute the chain, essentially. It's pretty straightforward in regards to the naming, which is one of the things Robert was insisting. Therefore, resuming part of the framework, we see that, okay, we have a parent chainer, which is this one that we're seeing on screen. The definitions are completely decoupled from one another, therefore they can be reused, they can be more easily managed, they can be deployed independently, they don't depend on one another, and therefore we can also link as many jobs as we want, because they're going to be executed sequentially, and one, for example, in this case for the chainable, for the schedule, at the end of the schedule is going to trigger the enqueue job for the second one, but that will be more of a task for the framework to do. It's abstracted from us. And even though that it's not shown in the example, there's also the ability to share information between jobs and also being decoupled between one another if we need to share information between them. So, one quick detail that is very usable for many developers, that we're talking about chains. I'm going to say chains a lot in this session. And well, the then method usually also returns the same instance. Therefore, that enables us to use this chain syntax, so we can chain the different method calls together without having to use the same variable, which is very popular for the ones that use this framework. Yet, with this, there is still a challenge that persists. And this and we see that with complex use cases, which is, for example, when we have multiple automations that leverage this kind of concept, which is, for example, when we have a transaction that spans multiple objects. Let's see one example of this. We are talking about opportunities, right? So we have the opportunity object that is going to call that chain that we were talking before. Therefore, we have this chain. What would happen if that trigger, or maybe there's a roll-up summary that triggers the account trigger? And what would happen if the account trigger would also have its own chainable implementation? As you might guess, that would mean that we have two separate chains running in parallel. And that doesn't necessarily mean that that is bad. That could be intentional because it might be very good and useful for our use case. But there are times that it's not. And why? We might come across race conditions, log contentions, which are very, very difficult to debug, to replicate, and so on. It leads to unexpected results and also can jeopardize asynchronous limits. You might know that if we're already in an asynchronous context, we cannot branch out to more asynchronous jobs because it's also part of the limitations we have in the platform. So for this, who orchestrates the orchestrators? We cannot really tie to if we have the opportunity in the account. who really knows when the transaction ends and orchestrates the different chains? We have not talked about deferrable. We've talked about chainable. And that's pretty much what you might have been thinking. If this has been developed by Robert, what the heck is doing Jonathan on stage? And this is pretty much the contribution that your speaker has done to the project. When we have this use case of multi-automation or multiple objects or multi-automation, because it could also happen when we are working with a trigger framework that decouples the different automation for a single object, it could also happen. So we're talking about this implementation for the opportunity object, right? The same we were seeing before. And we might have a similar one, in this case, a made-up one for the purpose of this session, that it's triggered from the account object. So we're seeing that this is the representation of the problem. And from the perspective of the developer that it's going to orchestrate these processes, there's going to be a very simple change. And it's this one. Instead of using the execute method, it's going to be the execute deferred method. And what this will do is that at the moment we are executing this method, it's going to grab that chain, it's going to unlink it, and it's going to put it in a queue. Therefore, if it's a queue, when the time comes in the same transaction that the account trigger is triggered, the same will happen. It would unlink that chain, it put it at the end of the queue. So we have all those chain links in the queue. So at the end of the transaction, what will happen in the framework is that it will take that queue and rebuild it automatically. Therefore, it will internally look something like this. So the chain is being rebuilt in a way so we don't have to really have control on who is going first, who is going second. It doesn't matter for us in this case. And you might have been thinking, okay, how is this working? How is this really working internally to orchestrate itself? Well, really, what you're seeing, those chain links are really platform events. The instances are being serialized into platform events and are being published in the kind of platform event that it's published after commit. Therefore, that queue, it's both the transactional queue, the commit, when you commit something to the database, or well, you issue the DML or the publish command, or the publish statement, we have that queue before everything is committed to the database, so in this case, to the event bus queue. Therefore, when we are subscribing to these events using Apex triggers or platform event subscribing flows, therefore, that's the other part of the implementation. When we are grabbing all those events, we have all of them at the end of the transaction because we are receiving all of them. That's the beauty of platform events and Apex triggers or platform event trigger flows. And that's the moment where we already have all the context of all the transaction and we are able to rebuild the chain. So they can be called in a sequential manner. There's a session tomorrow, I think at 2, where you can see more about Apex triggers and how to take the most advantage of those using platform events and Apex triggers. Be sure to take a look at that session if you're interested in that. Here's a slide of some resources about the asynchronous processes, about obviously the GitHub repository, and more info about this if you're interested. And thank you all. I really enjoy it. I hope you enjoy it too. And do not forget about the developer keynote. It's not every day that we have a keynote for developers. And also, please, I would really appreciate if you can leave some feedback for the session. Thank you very much.